Welcome to the Interop. Today, my guest is Nick White. He's the COO at Celestia. It's the first modular blockchain network, and it just launched a month ago. Today, we're going to be diving into Celestia. We'll talk about data availability sampling and the role of light nodes. We'll also discuss the other nodes that secure the Celestia network. We'll discuss Ethereum's role in Celestia's go-to-market and look at Blobstream, which is a new product that allows Ethereum L2s to leverage Celestia's data availability. We'll also discuss the increasing competition in the data availability landscape and other projects coming into this space, and we'll look at some of the few early projects that are already building on Celestia. I'm also dying to find out why he thinks the EVM isn't the be-all, end-all in crypto. Before we get started, make sure to hit the like button and subscribe to get notified when new episodes come out every week. And remember that none of what we discuss here on the Interop is investment advice. And if you would like this content, please consider staking with us. We are validating on FMOS, Quicksilver, Osmosis, and Juno. Just look for Interop in the active set. My guest, Nick White, is coming up next, right here on the Interop. Nick, thanks for joining me on the podcast.
Seb, really glad to be on with you and excited to talk about all the things modular.
Yeah, so Celestia launched just about a month, well, it was a month ago yesterday. So congrats on the launch. It's been a long time coming, and you must be excited.
Definitely. It was a huge effort over multiple years. You know, the Lazy Ledger white paper was originally published in 2019. And so it took, the better part of 4 years to take it from white paper to actual protocol. And I think it's a big moment for the industry because we're really entering this modular era where now we have the first, modular data availability layer with data availability sampling, and I think it's going to unlock a lot of new use cases and applications and things for people to build. So we're really excited and just I think it was worth all the work.
Yeah, Celestia has really created this narrative, the modular narrative. I think was coined by Celestia, and we had Mustafa and Ismail back on the podcast on Epicenter in 2019 talking about Lazy Ledger. And I remember doing that episode and thinking back then, it really wasn't obvious what this was going to be used for, right? There was this idea that you would have this kind of lazy blockchain that would just prove the existence of data. And I don't think they had really yet explore this idea of modular blockchains, or at least that narrative, or that sort of stack construction wasn't really fully formed yet. And then sometime later it was okay, this is now Celestia, and it's the modular stack and data availability, and they really sort of coined that whole new narrative in the ecosystem. Since the launch, what has been the reception from the broader crypto ecosystem, and do you see this do you really see this kind of shift happening in people's minds that now there's another way to build blockchains?
I definitely see it. Yeah, I think it's interesting actually in the first blog post that Lazy Ledger published as a project, Mustafa says we envision a world of modular data availability layers and execution layers. And so that was kind of the birth. I think that back in 2019, that was kind of the birth of this word modular, right? And then it kind of grew into the core way to sort of explain the difference between Celestia's view of blockchain architectures and the traditional monolithic architectures that have existed since Bitcoin, Ethereum, Solana, all the other popular L1s. And I think that steadily, at first it was just kind of the seed of an idea, and it didn't really it took, I think, another major leap forward was also the idea of rollups, right? So John Adler, one of the other co-founders of Celestia, came up with the construction of a like optimistic rollup. And I think that was kind of the perfect complement to this idea of a lazy ledger that's just data availability. And so it's the combination of those two things that unlocked this completely new architecture that we now call modular blockchains. And I think over the past few years, Celestia has been trying to, evangelize and educate the broader crypto community about this new way to do things. And I think slowly but surely, people have been sort of converted and nerd sniped into this new architecture because it has all these advantages, from scalability to better to verify. You have things like light nodes, which I'm sure we'll talk about, and then you have all this added flexibility for developers. When you can spin up your own custom chain, you can do things that you just couldn't do in a monolithic framework where you're locked within the EVM, sharing the same sort of like execution resources as all the other applications. And so I think it just kind of was inevitable that eventually people kind of were won over into this new way of doing things. And I think now that we're live, it's no longer about the theory, but it's about putting it into practice.
Yeah, that's interesting, right? I mean, when you talk about people being able to launch their own chain, that was the Cosmos vision. I mean, it still is sort of the Cosmos vision and the app chain vision, but Cosmos sort of took it a step. Like, I mean, it was very visionary in terms of having that execution sovereignty for your own application. But I think, or at least like I never really considered when those concepts first started emerging back in like 2017, 2018, just the cost of security, the cost of securing your own chain when you have to run your own validator set and when you have to sort of manage every aspect of your chain. And it's sort of like we went from shared web hosting, right? If you sort of take the Web 2 analogy, which I like to do, you went from shared web hosting to everyone runs their own data center, to now somewhere in the middle where we have shared infrastructure. You're still leveraging some shared infrastructure in terms of data availability and perhaps security. We'll talk about Ethereum and how that fits in, but essentially the application is sort of containerized and sort of like lives on top of this shared security model. And there's still a world in which some applications are going to want to like do their own data center thing, right? Like Osmosis and DYDX and applications that have a lot of users, that have a complex execution environment that requires also to be able to control the consensus, the governance, MEV, things of that nature. But for most applications, that's not going to be the case. And so, I wonder, do you anticipate a lot of the Cosmos app chains that launched in the last 3 to 4 years to become rollups, like to give up their validator set or supplement their security with or the data availability with Celestia, and maybe supplement their security with Ethereum or some other kind of modular security construction like that?
I think, I'm really glad that you brought up this sort of analogy of comparing the different architectures to sort of like traditional Web 2, like Web 3 architectures to Web 2 architectures. And I think, Ethereum or these monolithic protocols are very similar to shared web hosting providers, where like everyone's kind of like using the same infrastructure, but then you're kind of like stuck within whatever like frameworks that they support. So like that's like EVM or SVM, right? And you're ultimately kind of like limited in the flexibility and scalability of your system. So then, if the next one is sort of like the Cosmos vision of everyone should run their own chain, right? Rather than launching on a shared chain, run your own chain. You can have customization. You have more scalability because you have dedicated infrastructure, and I think that's a step forward for certain things. But then the Celestia vision is sort of like the synthesis of that, and it's a lot more like cloud infrastructure, where instead of having a data center where you launch a virtual machine, you have a data network like Celestia where you launch a virtual blockchain, which is a rollup, and then you get the best of both worlds. In that, like when you launch your own chain, it's like building your own data center. It's a huge capital expenditure. It's also a lot of like operational, like ongoing OpEx costs, and so it doesn't make sense for everyone to do that because it's a lot to take on. Whereas with Celestia, you can, or like if you launch on a data center like AWS, it's like, oh, it's out of the box, it's on demand. You get the same amount of flexibility. You like a benefit of these economies of scale, right? That AWS can provide to all these developers. And so Celestia is the same thing, but applied to blockchains. And so like rather than launching your own blockchain, you have this blockchain as a protocol, blockchain as a service kind of thing. Protocol as a service, essentially, that provides the consensus and data availability for you to launch your own thing. And I think, one of the biggest benefits is that you don't have to go through the trouble of actually bootstrapping a validator set, issuing a new proof of stake coin, all these things in order to launch your network, because that is actually a significant lift. And then on an ongoing basis, you don't have to pay for the security budget, right? And I think one of the things that we saw, at least in the Cosmos ecosystem over the last bear market, was that like a lot of chains were kind of struggling to pay for their security budget. Like, you're having to have 100 validators run these nodes. That cost adds up, and then you're also issuing all this inflation on your token to pay for that. So I think there is a big economic incentive or reason for these Cosmos chains to migrate to something like Celestia. Now I don't know if the existing ones will, because they've already kind of gone through the effort, right? But I do think that going forward, when new people want to launch app chains, it just makes a lot more sense to build in this kind of model, unless, like you said, you are like a DYDX or Osmosis, or you have a specific need for your own dedicated infrastructure.
So there's been this build whatever stuff that I've been seeing on Twitter, and people have been tweeting build whatever. What's the deal with build whatever?
Good question. Well, build whatever is sort of this rallying cry / motto that the Celestia ecosystem and the modular ecosystem have sort of come up with, and it reflects this idea that people should be free, developers should be free to build whatever they want, right? And that there's a lot of different layers to that. One is, one of the goals of the modular stack is to remove constraints. So those constraints could be things like, hey, I'm stuck with, paying really high fees. So like increasing the scalability so that like you don't have to worry about the fees that you incur for users, right? Another one could be just breaking free from like limiting yourself to certain execution environments, like building within the EVM or the SVM. When you have the flexibility to define your own execution environment, it opens up a whole new range of possibilities. And so like removing constraints from developers is, I think, one of the like main selling points of the modular architecture. Now, in addition to that, build whatever is also about this idea of just like go out and explore, and like you have all these different components that you can now mix and match, and there's all these like new possibilities. It's a new frontier, and so people should just go out there and like YOLO it. You know what I mean? Yeet some new applications into the cryptoverse, and then just see what happens. It's sort of like this. It's like, we're on the frontier of such a new era in crypto, and it's kind of like come join and like build something. And so I don't know. I'm really excited because a lot of people are kind of like getting into that mode of thinking, and I think it's what we need to unlock this next wave of innovation in the space.
What's the most extreme thing that someone has built on top of Celestia so far?
Good question. I think
in terms of departing away from like a regular blockchain application.
Good question. Well, I mean, there's a lot of different like new things that you can do. I mean, one example that I really like as an example of build whatever is just is actually Eclipse, because they are kind of combining like a bunch of different components in a way that like no one would expect. So specifically, Eclipse is a Solana virtual machine rollup that's launching on Celestia for data availability, but Ethereum for settlement, and then using RISC-0 as their sort of fault-proof system. And so what I find so interesting about that is it's like bridging Solana, Celestia, and Ethereum, and like RISC-0, all kind of combining them all into one thing. And that's just something that I think if you rewound the clock like a year ago, or even to this day, it like no one could have seen that coming, right? And I think this is what we're going to see more and more with the modular stack, is people just like combining these things that probably no one would have expected, essentially. So That's one example. Another thing is just like net new applications, things like ephemeral blockchains is another like example of like just something that's net new on the modular stack, where you can actually spin up a rollup and do an NFT mint or something like that, and then wind it down. Like we're used to thinking about blockchains as like these permanent things, but actually in a modular world, like there's no reason why they couldn't be short-lived and just temporary. The same way that you would maybe spin up a server, to run like a ticket sale on a website and then like wind it down. So I don't know. Those are just some ideas off the top of my head.
Okay, interesting. So then you could sort of run your own blockchain, have the blockchain commit data to Celestia. That data would always be there. You would always be able to verify that data exists. You just can't issue new transactions after a certain point because the blockchain and the settlement mechanism and the execution environment no longer exists.
Yeah, I guess anyone could still post to that namespace on Celestia, but the thing is that there's no one's using it anymore. It's sort of like it was just like it's kind of like a smart contract that you create and then you just like kind of like deprecate.
Okay, interesting. So let's talk about data availability sampling, because that's, I think, one of the major innovations here. Now, this light node meme has been all over the place. It's sort of also one of the very strong Celestia memes is the light node meme. In fact, I was at this event you guys hosted in Istanbul, which was really cool, and you had like light nodes all over the place. It was very like futuristic. It felt like I was in the Matrix or something like that. Yeah, I think one thing that kind of clicked for me last night, we hosted a Celestia meetup in Paris. It was like the first Celestia meetup, and I was talking to folks, and they were talking about how light nodes don't just scale, but they allow Celestia to scale exponentially. And so I'd like you to maybe explain how light nodes work and how they actually scale in this exponential way.
Yeah, sure. So, I'm glad that we're talking about light node. First of all, I'm so stoked that there was a modular meetup in Paris. I want to hear more about it. I see that you're wearing the T-shirt. You should show everyone the back of the T-shirt. I think it says Celestia Light Start. Yeah, so that's on the command line when you want to start your light node. That's the command that you enter. So anyway, so light nodes are really important because they're a net new node type in blockchain. So what blockchains are at the end of the day are verifiable computers where a group of people agree to a set of rules, and then we enforce those rules by running nodes that audit the chain and make sure that, hey, the chain is actually like authentic. No, like the chain is following the rules and no one's breaking the rules, right? So nodes are like core to what blockchains are all about, because again, that's how the users verify and enforce the rules. Now, the problem is that in traditional monolithic blockchains, running a node means that you have to download and verify every single transaction, and that doesn't scale. And this is the fundamental reason why monolithic blockchains don't scale, is that in such a system, as there's more transactions that the blockchain needs to process, you have to download and verify that many more transactions. And so at a certain point, you've maxed out on what your computer, let's say your laptop or your phone, can process. And now all of a sudden, now you as a user can no longer run a node. So now you have to fall back to a trusted system where you're trusting someone else who's running a node on your behalf. And the beautiful thing about modular blockchains and what Celestia has built with data availability sampling is it changes what the requirements are to run a node. And what it is essentially in a modular blockchain, rather than having to download every transaction and verify every transaction one by one, if you want to verify the chain, you just download a small sample of the underlying block data. You sample randomly from the block data, and that helps you verify that the data is available, the data was published. And then what that enables you to do is verify a proof, either a fraud or a ZK proof, that the execution of those transactions was done according to the rules of the chain. And so with those two things together, all of a sudden you can verify the blockchain, and that requires an amount of work that does not grow very much with an increase in the number of transactions on the chain. And so all of a sudden you have this ability to actually scale the throughput of the chain, the number of transactions, without pricing out the average users. And so that, what I was just describing of like sampling randomly and verifying proofs, is what like a light node is. And so specifically, what's so cool about it is it's so light, in fact, that you can run it on a smartphone, or on like, even people have done it on Kindles or Nintendo's like game consoles, or like just random, all these like any kind of like hardware device you can think of. People have been running light nodes just as a way to demonstrate that they're so light that you can run them anywhere. And we've even run them like in really remote places with barely any internet connection, on planes. You can really, like, they're so light that like the idea is that anyone anywhere with any device can actually verify the chain. And then the scaling part, the other side of what light nodes do, is not just that they enable users to verify the chain really efficiently, but they also power the scalability of the underlying network in Celestia. Because the way that the data availability sampling scheme works is that the more people who are sampling the block, the bigger the block can grow securely. And so it's not exponential, though. It's more of a linear relationship of the number of nodes increases the size of the block can be in a linear way. However, I think maybe what they were referring to when they were saying exponential scaling is the fact that the amount of work that you do as a light node scales as the square root of the size of the block. So that is exponential in the sense of like the growth in the block size does not increase. It starts to increase almost like really slows down in the increase of work as it gets bigger and bigger. So there's this economy of scale and kind of this exponential nature to the way that the block size can increase without increasing the work that a node has to do.
Okay, so even if the block size increases, a light node doesn't, like the load on a light node does not increase linearly with the size of the block.
Yes, it increases as the square root. But the number of light nodes that you need to securely sample a certain size of block increases linearly with the block size. So let's say like we went from 2 megabyte blocks to 4 megabyte blocks. You're going to need, so the block size just doubled, you're going to need twice as many light nodes. However, the work that each individual light node has to do did not grow linearly. It stayed actually quite flat.
Right. Okay. Is there like do you think because light nodes are allowing Celestia to scale? I mean, for the moment, like light nodes are not remunerated for this work, right? But is there a future in which light nodes could be receiving some kind of fee, like some rev share for essentially running? Validators make the lion's share of inflation and like fee rewards, but like light nodes are also allowing the network to scale in that respect. Is that something that's like being explored or that could potentially work, or does that does not work at all?
It's something that we're definitely interested in. The problem is that light nodes are not Sybil resistant, meaning that if say we wanted to incentivize or reward light node operators, there's no way to stop someone from just spinning up 1 million of them and kind of capturing an unfair amount of the rewards for themselves. And so as opposed to like validators, like there is Sybil resistance because there's proof of stake. You have to put up stake to be part of the active validator set. And so that's really the challenge here. So maybe in the future, if there's some kind of like identity system or something, some way of, gaining Sybil resistance, then that could make sense. But so far, that's an age-old problem. And so far, I don't think there's yet a good solution, but I'm not saying that there wouldn't be in the future. And that would be really awesome, I think. However, I'll also say that, running a light node, first of all, is going to be extremely cheap. Like really, really cheap. Like you won't notice it if it's running in the background. And it's also going to be embedded in wallets and in browsers and things, so that in a way that like a lot of users won't even necessarily be aware. They won't have to have any expertise to do so. It's kind of just going to be part of like using a blockchain in the future. That's the way we envision it, and that's the kind of the thing that we're working towards. And in the same way that and like the incentive to do it, like the way I talk about this is like, why run a light node? It's sort of like the same question as like, why lock your house? It's like, yeah, you know, I wish I lived in a neighborhood or in a world where like I didn't have to worry about, you know, leaving my house unlocked. But the reality is I do, because we can't just trust people not to like walk into our house and like steal everything. And the same thing, like running a light node is like, as more and more of our assets are online, more and more of our lives are on blockchains, then it makes sense for us to just take the added, you know, amount of security to actually just verify and make sure that like there's nothing like wrong is happening. And it's very similar to a lock, right? A lock is a very low effort thing. It's like, oh, it just takes me 1 second when I leave. It's the same thing with running a light node. It's like, you know, I don't even notice it, but it's something that gives me a feeling of safety and assurance that, you know, my online life, my on-chain life is safe.
Yeah. No, I think that's kind of the holy grail, right? Because right now, if you're interacting with any blockchain through a wallet, you're most likely, unless you're running your own node or your own client, using someone else's RPC. Now, you can do that in a trust minimized way, but you still have that liveness risk. And you know, if Infura goes down or Alchemy goes down, then you know, so does all of Web3. And so that's why, you know, I'm quite bullish on teams like Lava Network that are building a marketplace for RPC providers and data APIs, you know, for blockchains.
Mm-hmm.
Disclaimer: we're investors in Lava, but for Celestia, you know, if the light node can just be embedded in browsers, right, to the point where, you know, if Celestia like basically, you know, gets the lobby to W3C to make this kind of a web standard, and it just like, I don't know what organization, but or maybe just browser manufacturers or developers. Then yeah, you can have the light node right in your browser. Every time you launch your browser, your light node is running in the background, or like right in the wallet, mm-hmm. On a phone, and then you're not relying on someone else to do that verification for you. You're doing it by yourself, and there's, I think, a tremendous benefit to that. And then it's all about, you know, creating the right, you know, UX abstractions to let users know that their data is in fact, you know, on the blockchain, the same way we have, you know, SSL, you know, locks on our little icons on our exactly. browser that shows us that we're using a safe connection. So I think it's very cool. So what are the other types of nodes? So like last night at the meetup, we were talking about the different types of nodes, and I realized I wasn't like super aware of the two other types of nodes that exist in Celestia. So could you explain like what are the different roles here? Yeah.
Before I do that, I want to just respond to sort of part of what you were saying, because it's a really good point about RPCs. Like, you know, the way the majority of users currently interact with blockchain applications is via RPC, right? So there's a few different problems with that, and actually Moxie, you know, who's sort of like a crypto OG, he wrote this long critique about crypto. I don't know if it was last year or the year before, and one of his big points was like, everyone uses, all of the users just use RPCs, and so like this whole like trust minimization thing doesn't actually like count in practice, because basically what happens if you're using RPC, first of all, you're not actually verifying the chain yourself, so you're again like trusting someone else to verify it for you and tell you the truth, right? So that's a really big one, because then you're making an honest majority assumption on either the validators, or you're just fully trusting whatever this RPC person tells you. Like, hey, this is your balance. This is, the transaction went through. How do you actually know? You don't know. You're just trusting that end provider, right? So that's one issue. And the other issue is that, like you said, you know, all your transactions have to route through them. So it's not really a peer-to-peer network in the realist sense, right? because you're not actually connected to the network. You're connected, via proxy to the network. And so the cool thing about light nodes is that they flip this on its head, and every user is their own sort of like RPC in a sense. They're verifying everything themselves directly by running the light node, and they are actually directly connected to the peer-to-peer network of the chain. And so they're sending their transactions directly to the network, not through someone else. And we just think that's the future. That's actually what I think blockchains always meant and aspired to be, but we had to take shortcuts because of the limitations of the infrastructure back at the time. So like light nodes, I think will also like deliver us to this much more decentralized, secure place for blockchain architecture. Now, in terms of other nodes that we have, so there are validator nodes, right? So they are the ones that are actually voting on blocks and minting new blocks into the chain. Then you have what we call bridge nodes, which bridge from the sort of the consensus network to the data availability network, because currently those are two separate networks that overlap via the bridge nodes. And so the bridge nodes kind of facilitate this communication between the consensus and the data availability networks. And then you have data availability nodes who are more just, checking that the data is available. And there's different sort of tiers of those. Some you can have like an archival node that's storing everything. Eventually we're going to implement pruning. That's like the next closest thing on our roadmap, so that data availability nodes don't have to store data forever. And then you kind of have tiers. Eventually we'll have partial nodes that if you want to, for example, just listen to a specific namespace and store that data, you can do that. And then we have light nodes, which are just doing the bare bones sampling of the underlying block data to verify that the data is available, but they're not necessarily like, actually downloading the full data in the block.
So you've mentioned namespaces a couple of times already. So can you explain what this is and how it relates to applications?
Yeah. So, one of the benefits that Celestia has is that, as compared to other L1s, is that it was designed specifically for this rollup centric world, right? It's an L1 that is built to provide scalability and security for rollups, and a better user experience for rollup developers. And so one of the key things that makes Celestia unique is this idea of a namespace Merkle tree. So all the data that gets posted to Celestia is organized in a certain way that makes it really easy for someone who's using Celestia to just listen or sort of pull the specific data that is relevant to them. And that data is in a particular namespace. You can think of this as like an address, like the same way that Ethereum smart contracts have a contract address. It's a similar thing, where all the data associated with a given rollup lives in a certain namespace address. And this just makes it way more efficient to, for example, prove the inclusion of certain data in a Celestia block, and also to pull that data, the specific data that you care about, for your rollup, rather than having to sort through. If it wasn't organized that way, you'd have to find some other way of filtering out and sorting through the specific data that you care about.
Does that introduce any issues with potential collisions or having to check I don't know. I mean, does that introduce any problems also with applications maybe that are wanting to interoperate, where an application might want to check the data from another namespace? Does that make sense?
Yeah. So, one of the cool things, so Celestia also one of the benefits is it's really helpful for chains that want to interoperate with each other for a host of reasons. But essentially, let's take an example of those two separate chains that are running, in parallel with each other, but they don't share a common consensus and data layer like Celestia. Then when they want to interoperate, they don't have a way of verifying seeing directly the sort of consensus and the data availability of the other chain. And that means that they end up having to trust the other validator set. And whereas if they are running both these rollups, both these chains are rollups that are running, posting their data to Celestia, they're already natively verifying each other's data availability because they're both their data is being posted to the same underlying data layer, right? So when this one's nodes verify the data availability for its own chain, they're also indirectly verifying the data availability of this other chain. And there's nothing stopping, since they're also now connected, those nodes are all connected to the same like core network. It's really easy for these nodes to say, hey, I actually want to pull some data from this namespace and look at that and see what's going on. So it becomes very easy for that kind of interoperability to take place. And also another thing that they know the ordering of each other's blocks that way because they're both following the ordering of the underlying Celestia consensus blocks. So there's a lot of benefits for interoperability within a Celestia-like paradigm.
Cool. I want to talk about Ethereum because over the last couple of days, I've become aware that Ethereum is a much larger part of Celestia's go-to-market as I had initially anticipated. See, I just thought Celestia would be this chain that would host rollups and like live in its own ecosystem. But you guys recently announced Blobstream, and Blobstream, the way I understand it, is a way to allow Ethereum L2s to use Celestia's data availability while still sending proofs to Ethereum, while still sort of committing to Ethereum, and that effectively allows them to reduce the cost of data availability on Ethereum. And it's a really great, I think, product strategy because if you're an Ethereum L2, there's sort of like no reason not to do this, right? If you care about cost. So yeah, sort of given some high level context here for Blobstream, but yeah, how important is Ethereum and sort of EVM L2s in the broader like Celestia go to market and product vision?
That's a great question. So Ethereum, so there's a long history of Celestia and Ethereum, and in fact, Lazy Ledger, the original idea behind Celestia, was initially envisioned as an Ethereum sidechain. Like the hope was like, hey, we can enhance Ethereum with data availability sampling and like a whole new capability for the Ethereum protocol itself. But then it turns out essentially that there are limitations to doing any kind of data availability as a sidechain to Ethereum. For that reason, it turned out that we have to essentially launch our own network with our own token to build this. And that is because basically you can't actually, there's no way for an Ethereum smart contract to verify the data availability of another chain. It has to be done in the protocol, in the nodes themselves, because data availability withholding is an unattributable fault. Anyway, we can talk about that all later, but basically, and another kind of overlap with Ethereum is that a lot of the original ideas for Celestia were proposed in the Ethereum research forum. And so like a lot of what Celestia is kind of like born out of the same values and research community as the original like Ethereum community. So obviously one of the major goals for us when we were launching Celestia was to help to supplement Ethereum with additional data availability, because we saw that as a real need for their ecosystem, because there's a lot of rollups on Ethereum already. There's the demand to launch even more rollups. But the problem is there's just this really constrained supply of data availability on the Ethereum L1, and that leads to really high fees for these rollups and makes it kind of, you kind of almost have to be a VC-backed, rollup team to be able to like afford launching and operating a rollup on Ethereum is sort of the state of things today. And so we wanted to provide something to the Ethereum community that would enable the cost of operating a rollup and L2 on Ethereum to be significantly lower. And that's basically what Blobstream is it enables you as a L2 builder in the Ethereum community to settle on Ethereum, like still have your rollup be based and rooted in Ethereum, but use Celestia for data availability. And Celestia's Blobstream basically routes it, sort of forwards or relays a commitment to that data to the Ethereum L1 where it gets verified. And then that is like the rollup contract that you deploy on Ethereum can then look at that bridge, the Blobstream bridge, and verify that the data is actually available. So the benefit here is we can drop the cost of operating a rollup on Ethereum or an L2 on Ethereum by orders of magnitude. And so we're really looking forward to sort of like opening up the floodgates of like all these people who I think have been waiting to deploy L2s, but have kind of been blocked on just the underlying cost. And the good thing is too that like there's other solutions, right? Like data availability committees that people have talked about or have launched. But the difference is a data availability committee is basically just is a very like strong trust assumption on the operators of that committee that they're not going to rug you, right? And the good thing is that Celestia is a decentralized blockchain with many, many validators, as well as the fact that it has actually crypto economic stake behind it. So you have this much higher security guarantee than if you use a standard data availability committee. And you in order to do that, you need to actually have a separate chain. Like you actually can't use Ethereum as a restaking sort of collateral to secure an off-chain data availability service. So I think Celestia is kind of like, through Blobstream, is kind of the optimal source of DA that can exist outside of like the Ethereum L1 itself.
And what about existing L2s? You talked about these new L2s that want to launch on Ethereum, and where the cost might be prohibitive. Can existing L2s, like say Arbitrum or some of the ZK VMs, could they leverage this as well and transition to using Celestia data availability?
They absolutely could, and I think that's a decision that's up to them and their community, right? And there are security trade-offs, right? Like when you post all your data to Ethereum, right, you have the full sort of like DA guarantees of Ethereum itself, right? And that's really, I would say, the top tier security that you could get for an Ethereum rollup. Like if that's where you want to be, that's the best you can do. However, it's really expensive. So it's a kind of a trade-off for them. It's like, okay, well, do you want to, if they migrate to Celestia, they can save a huge amount on their fees and still achieve a pretty good degree of security. Now, it won't be as high as Ethereum, but I think it's like, for the most part, like, really, really strong and probably sufficient for a lot of these use cases. So it really comes down to their decision about like what is the trade-off of cost and security that makes the most sense for them. The one thing that I'll say is that in a Blobstream, like Celestia off-chain DA type of security model, the Celestia validators could always lie to you, right, and withhold data, and in so doing, they could steal funds in the bridge, for example. So you have to consider the risk that way of like, okay, well, how many bridge funds are at risk that the Celestia validators could feasibly, well, the Celestia validators in combination with the rollup operator could feasibly steal if they wanted to. And is that amount of value going to be more or less than the amount of value at stake in the Celestia protocol? Because if it's more, then it could be rational. It could make rational sense for the validators to do such an attack. But if it's less, then it's like, well, why would they do that? Because they would lose more money than they would gain.
Okay, so here you're talking about the bridge. So you're talking about the bridge between the Celestia data availability layer and the Blobstream contract on Ethereum.
I'm talking about, so there's multiple bridges in this. This is where modular blockchains get really
fun. Where are the bridges?
So, so you can think of a rollup right as its own chain, and then they have a bridge to Ethereum, right? And so assets on Ethereum get deposited in this bridge, and then they appear on the rollup. And so one of the things you have to protect against as a rollup is that the funds in the Ethereum bridge get stolen, right? So let's say you have $1 billion worth of ETH in that bridge. If the rollup operator is able to withhold data, they can post like a fraudulent sort of like header to the Ethereum bridge contract that transfers all the ownership of all that ETH to themselves. if that makes sense. But in order to do that, they have to be able to withhold data. So that's where the Celestia bridge comes in. That what could happen is the Celestia validators would post something to the via Blobstream to Ethereum saying, "Hey, we've ensured this data is available," when actually it's not. And if they do that, then the rollup operator could then post a header to the bridge that steals all the funds. Now, if the data was actually available, someone would be able to post a fraud proof, or there'd be a way to prevent that from happening. So hopefully that makes sense. There's like 3 chains in this situation: Celestia, Ethereum, and the rollup, and they each like interact in different ways.
Okay, and the fact that Celestia, so the way I see this is like there's the L2. The L2 is sending proofs to Ethereum, right? And
Yep.
it continues to send like validity proofs or fraud proofs to Ethereum, and then the transaction data gets sent to Celestia, and then that transaction data also makes it into the contract because Celestia. So it's you guys have this diagram on the website. And it's like
Yep.
the L2 is in the middle, Celestia and Ethereum. It kind of goes like each way, and so the fact that Celestia is also sending an attestation of the DA, so essentially a proof that that data has been successfully committed to Celestia to Ethereum. Does that not mitigate some of this?
It does, in the sense of now, if someone wanted to lie about the data being available to the bridge contract on Ethereum, they would have to like get the whole validator set of Celestia to collude to do so. And if they did that, also the Celestia validator set would get slashed for withholding data. And so there's a huge cost. Not only is it hard to coordinate that, but also there would be a huge economic cost to someone doing that. So that's the way in which it works. Yeah.
Okay. And I also read about this Ethereum fallback for the OP stack. How is that related to Blobstream?
Yeah, so this is something that we're really excited about. It's this idea that so let's say you're a rollup, right, posting your data, your transaction data to Celestia. You're then kind of like dependent on Celestia to make sure that your rollup can continue to operate, right? But in case there's any sort of like disruption to the like Celestia service for whatever reason, it could be network downtime, or it could be congestion, or there could be lots of different reasons why for some reason the service is no longer like available for like maybe temporarily. The good news is that you can build in this fallback mechanism whereby, okay, I'm having trouble posting my data to Celestia for whatever reason, I'm going to post it to Ethereum directly instead. And so what's nice about that is it provides you this like backstop of service reliability of Ethereum itself. So you don't, as a rollup operator now, if you're running an L2 that uses Celestia for DA, like you can sleep better at night knowing that like, well, at the worst case, I can always post my data to Ethereum. Now, what I want to note, just so that people are clear, doesn't mean that you have Ethereum level data availability guarantees. It's like the Celestia validator set could still withhold data. It's more about this like sort of like uptime / reliability that it gives you. It's just cool because again, this is another example of how modular blockchains just kind of like enable these new things that there's no analog to other chains. It's like, wow, I can use either or. I can use Celestia or Ethereum at the same time, and get the best of both worlds from that perspective. And it's kind of magical. I call it modular magic.
Cool. So I think like in the last few months, there's been this narrative that has been kind of coming up, at least in Cosmos, about alignment, right? Like, do applications want to align with the Cosmos Hub? Would applications align and supplement their security by committing also to Ethereum? And then there's ideas of things like mesh security, which could potentially also implicate Ethereum security or ETH restaking through eigenlayer. Where does Celestia fit within all this? And like in a world where mesh security exists and Cosmos app chains secure each other, potentially are also being secured by restaked ETH on eigenlayer. There's a couple of projects that are like very early projects that are working on this. How does Celestia sort of fit within this modular security future where chains are securing each other? Ethereum is also acting as security, maybe even Bitcoin through things like Babylon.
Good question. Well, yeah, there's quite a range of different approaches to solving these things of like, how do I secure my chain or whatever service that I'm trying to run? And I think that like eigenlayer or like restaking or interchain security, those kinds of approaches are actually quite different to the sort of like Celestia model of shared security, in the sense of what restaking does, or interchain security, is it enables you to reuse. Well, actually, even interchain security is slightly different than eigenlayer. But anyway, they allow you to reuse existing like assets to sort of like collateralize a new committee, right? To operate some kind of service. And so that you could use that to bootstrap a new consensus committee. Like every consensus network is a committee at the end of the day. Or you could use that to bootstrap a new committee for an oracle, right? Because every oracle also has to be a committee. So I guess like that saves you the problem of having to issue your own coin, for example, which is a big benefit. But the thing is, you're still having to bootstrap that set of validators and actors to run this service or this committee. And on top of that, what you're sharing, right, is the underlying asset. You're not actually sharing like actual security in terms of do these protocols know anything about each other? Are they actually able to verify each other more efficiently? Now, in the Celestia like version, right, you don't have to spin up a new committee. You actually plug in and use an existing consensus committee, which is the Celestia validators, to have consensus, and you just pay for that service. So it's very different from that perspective. You're not actually having to create a net new committee. And on top of that, these chains that sort of plug into Celestia, these rollups, actually are sharing security in a very real sense, that they are able to verify each other more directly, because like I was mentioning earlier, they're sampling the same underlying data availability layer. So it really is a completely different sort of like means of like thinking about what shared security means. And I think like also you can't really like, so what Celestia is also at the end of the day a scaling solution, in that what scalability is about verifying something more efficiently. Like the cost of verification does not scale linearly with the amount of transaction data that you can verify. Whereas like interchain security or restaking or things like that, they're not actually scaling or solving scalability. They're just creating net new things that you still need to verify with the same amount of effort, if that makes sense. Now, I guess like the difference is also that like with Celestia, if you wanted to launch a new chain with a, like net new consensus, that's not something that Celestia can offer you. Like you do need to bootstrap a new committee for something like that. So they're just sort of like different offerings, I guess. But actually, one thing just on my mesh security, what's really interesting is I've been having a lot of exchanges with Sunny over the past year or so about like mesh security and how it could work. And interestingly, like the only way that mesh security can work is if there's underlying data availability between these chains. Because if you are taking stake from one chain onto another, if these validators that you staked to with a non-native asset do something wrong, there's no way to prove to the issuer chain, that those assets should be slashed. And unless you have fraud proofs and data availability. So at the end of the day, like the security model for mesh security boils down to basically needing to run rollups and needing to have data availability. And so that's why there's like in the latest iterations of mesh security that I've seen, there's this idea of using Celestia as a shared DA layer to facilitate mesh security in the interchain.
I think you just like blew my mind on something. Are consumer chains in mesh security actually roll-ups to the provider chains?
They kind of, if you want it to actually be secure, then yes, they not necessarily roll-ups to the provider chains necessarily, but they need to be able to verify each other. And so they need to be roll-ups to a common data availability layer. That's the way that, otherwise there's no way for you to slash for misbehavior on another chain.
Right. So having your own, a consumer chain to a provider chain, even if it has its own validator set, would still need to post data to a shared data availability layer. It would be a roll up to that data availability layer because it is sending its data there, but it is still securing. It's still securing itself with its own validator set and securing other blockchains' state with its staked assets.
Yeah. So like, here's one way to think about it is like, okay, let's say we have Osmosis and I don't know, Neutron, right? And let's say they're doing mesh security. Osmosis, these people are taking Osmo and staking it via mesh security to like validators on Neutron. Now, when those
validators on Neutron are Cosmos validators.
Oh yeah, right. Okay, Neutron's a bad excuse. Like,
okay, all right. Let's talk about think of another things on the same semantic level.
Sorry, yeah. What's another? Name another Cosmos chain.
The Cosmos Hub.
Okay, yeah, Cosmos Hub. There we go. Whatever. Right. So now they're staking Osmo to validators on the Cosmos Hub. Now let's say the Cosmos Hub validators commit an invalid state transition. So they do something that is like just breaks the rules of the chain, but they've all signed it, right? The Osmosis validators have no way, the Osmosis nodes and network has no way of knowing that is actually fraudulent. All they can do is verify the signatures of that thing. They can't actually re-execute the state transitions of the...
They don't have the data.
Yeah, especially if there's data withholding, right? And so all of a sudden now it's like, hey, they're like, hey, we need to slash these guys because they just... The full nodes on the Cosmos Hub are like, hey, we need to slash these guys because they just like broke the rules. But then in order to slash them, the stake that was committed to here, Osmosis network and nodes need to understand that and be able to interpret that, but they can't unless they are sharing a common data availability layer and there's some kind of fraud or ZK proof system between them so they can verify, hey, like, yes, this is an invalid block that was signed by these guys, therefore we're going to slash all of them, including the Osmosis stake on our chain. So hopefully that...
I mean, they're using Blobstream, essentially. Like, they end up using Blobstream, right?
Yeah, in this case, they would be probably more... it would be better if they were just like native rollups and they're both posting their data directly to Celestia.
Okay, got it. Boy, this gets complicated real fast, but also gets really interesting.
Yeah.
Okay. Yeah, I've got to spend more time in mesh security. Like for now, it's just sort of like this nebulous concept that I've not spent a whole lot of time like digging deep into, and it just seems like there's a lot of really interesting stuff happening here. Great. Well, let's talk a little bit about other DA layers. It seems like a lot of other projects and teams are hopping on the DA narrative. There's like Avail. We had Anurag on the podcast recently. I think they're building something that's quite promising, but also very different from Celestia, potentially like especially on the consensus side, and also I think they have they have an ambition to like really have a much broader validator set, right? That has different trade-offs than the Tendermint consensus. And then also Near has announced that they're going to do some DA stuff, although I don't know very much about it for the moment. So this emerging landscape of DA protocols, like which are you the most impressed with, and what like in the future would it be useful for applications to post to multiple DAs to just increase the security provided to their application, or does that not make sense?
So the DA landscape is growing, which is great because, frankly, I feel like there's surprising to me that there's so few actual like dedicated DA solutions out there on the market, even in the fact that like we're 2023, almost 2024, right? And I kind of categorize them into two broad things. Like the first are genuine DA layers that are designed from the ground up specifically for this new future. And those also support data availability sampling, because data availability sampling is the gold standard in how you scale secure like bandwidth, like DA bandwidth. And so the only projects or protocols that I'm aware of that are doing that are Celestia, which is live, Avail, which is on testnet, and then dank sharding, which is still sort of like a proposal, but I think is either EIP 4844, which is proto dank sharding, which is kind of the first step towards that, is another one. And then you have a suite of these other solutions that are either like committee based, or they are existing L1s that, like Near, for example, who are saying, hey, well, we can be a DA solution too, right? And the reason I separate those two things is that like data availability sampling enables users to verify DA directly. It enables the DA throughput of the chain to scale with the number of users and nodes in the network, and provides you just the best security. Now, the other DA solutions like EigenDA or Near or whatever that don't support this just don't have the same scalability or security sort of like properties. And so to me, they're just not that interesting long term as actual like long term solutions to this underlying problem. So I guess so now kind of like setting that aside, comparing, for example, Celestia to Avail, I think a lot of there's a similar vision of creating a very like minimal DA layer with DAS. And I think where Avail is different is they, like you said, they have a different consensus algorithm. So they use Polkadot, Babe, Grandpa consensus, and they use a different way of committing to the data that uses KZG commitments. And what that means is that they we use a sort of a fraud proof mechanism, and then what they use is more of like a validity proof mechanism, is one way to think about it. And I think the real difference is ultimately in a lot of these cases with DA layers is like execution. Like there's a lot of theory, but like who can actually ship something that is scalable and that works well. And so I think like you'll see a lot of claims of like DA throughput probably circulating around on crypto Twitter, over the next year. And the real thing is like, well, the proof should be in the pudding, and like who can actually ship something that is really usable and actually efficient and effective. And I think so far, only Celestia is really live, so it's hard to tell and compare apples to apples between these DA solutions.
Yeah, I mean, it's a space that I think I'm trying to keep my pulse, my finger on the pulse here about the promising like DA layers, and I think obviously like Celestia has a huge advantage by being first to market, by having attracted all of these projects to build on Celestia and just solidified the narrative. But there will be others, and I think that it's going to be a landscape of multiple DA layers that will align with different ecosystems and sort of capture market share in different parts of crypto. So it's going to be interesting to watch that play out. Coming back to the ecosystem. So currently Celestia is still in beta, but applications are already starting to build there. What's the most exciting stuff that is currently being built on Celestia? Like I know I saw this Milky Way liquid staking project pop up in my Twitter feed the other day, and some other projects. So yeah, how many projects are building there? What are the things that people should be paying attention to?
Yeah, there's a lot. I think the first few that I'm like most excited about, and I'm probably going to leave out some, and because it's just inevitable. But one that I'm really excited about in the near term is Manta. Manta is like an EVM chain, but with like special opcodes that make it really efficient to verify various like snarks and ZK proofs. And what that enables is like, they've like built in all this like native functionality for like randomness or other like privacy, like ZK kind of functionality. And so it kind of is like this ecosystem for people to build really interesting applications that tap into that as like a fundamental building block. And they're currently a rollup on Ethereum, but they will, when we launch Blobstream, they're going to migrate their DA to Celestia while still settling to Ethereum. And there's just a whole bunch of people who are building applications on Manta that are currently just too expensive to actually be like, usable essentially. And so what like their whole community has basically been saying like, hey, when Celestia essentially. And I'm really excited because like it's going to unleash and enable all these new applications that their community has built to actually like flourish. And so that's a big one that's coming soon. Another one that I'm really excited for is Eclipse. They are launching a Solana virtual machine rollup. I think we talked about this earlier. And I think what's cool about Eclipse is that, Solana is the second biggest sort of developer ecosystem after Ethereum. And yet there's still only one Solana chain, right? Whereas like for Ethereum, there's been multiple EVM chains for many, many years, and there's all these different rollups. And so I think it'll be really interesting to see how the sort of like, does like how does the Solana ecosystem, like developer ecosystem, grow with this first non-Solana L1 SVM chain? And I think what's cool about it too is like that we're combining the best of both worlds, because I think Solana, to their credit, have built an amazing, virtual machine that has parallelization, has this like special gas fee sort of like market that makes things like more efficient. And I think Celestia brings this really scalable underlying DA. So you can kind of, by combining these two things, I think it could be really, really powerful, like a really fast, really efficient, really cheap blockchain on both the data availability and the execution sides. So that's another one that I'm excited about. I'm also excited about things like Argus. So Argus, and by the way, both Eclipse and Manta, for example, are using Blobstream and will be settling to Ethereum while using Celestia for DA. Argus, on the other hand, is a little bit different. It's an on-chain gaming project where they've built a specific VM that is tailor-made for on-chain gaming, and they have some games, I think, in the pipeline that will be ready to launch soon. And what's cool about it is that like it's another example of kind of build whatever, right? And the reason why this modular blockchain thing is so revolutionary is that they've people have been trying to build games within the EVM or Solana VM or like these sort of execution environments that are not actually designed from the ground up for this use case. So they've gone ahead and built a whole new execution environment that has a high tick rate, has like native sharding to be able to like scale the game worlds, and all these other features that are going to make gaming on Argus like just a superior experience. I think I'm really excited for them to launch, and I think on-chain gaming is another just good example of like a use case that Celestia enables uniquely, because on-chain gaming needs a lot of data throughput, and there's currently not really a good place for someone to launch something like that. And Celestia, just by the nature of having all this scalable block space, is making on-chain gaming possible in a way that it wasn't before.
Cool. I've noted down all of those to look into them.
Yeah, actually, I'll also mention another one that I'm really excited about, because there's a lot. So I also feel bad because I won't be able to remember all the best ones. But Dimension is a really interesting project.
Yeah, of course, Dimension.
And what they're building is sort of like a Cosmos SDK based sort of like roll up ecosystem with a hub that all these roll ups like settle down to. And they'll post their data to Celestia. And what's cool is that they have this like roller framework, which makes it really, really easy to deploy a new rollup. And so I think they're going to unleash just a crazy amount of like people just deploying rollups. I think currently on their testnet, they had already over 10,000 rollups deployed. So there's like, wow. That's how easy they made it, is that like, it really is just a few commands and you can deploy a rollup out of the box. And they've done a lot of work thinking through like, the product aspect and the user experience to make it really, really slick. So really excited for them to launch as well.
Great. Before we wrap up here, I wanted to ask you your thoughts on this. And so I've been thinking a lot about, as we enter this modular era, we've had of course like the Bitcoin era, which was like a singular blockchain doing a singular thing, and then we had the Ethereum EVM era, which was a virtual machine that was able to do multiple things and build, where people could build applications and dApps, but using a single purpose blockchain only built for like doing this one thing, right? Like running this VM. And now we have the modular era, where every application is essentially its own sovereign roll-up. I mean, that appears to be like where we're heading, where every application is its own roll-up. In this context, I think it appears like there is that there will be a shift from EVM-based applications to non-EVM-based applications, and the reason why I think this is going to happen is because the EVM was not built for this modular world. It was built like almost 10 years ago. It has a bunch of issues with security. Solidity is not like a very secure programming language. Has a bunch of issues that we have not resolved yet. It's not built for the modular stack, and now with these new VMs, whether it's the Cosmos SDK or Cosmwasm or the Solana VM or things like Move that are much more modern, that use programming languages like Rust, which are much better equipped, I think, for blockchains. I think developers that are coming into this space, that are coming out of college in the next 5 to 10 years are going to prefer to use those programming languages and those VMs rather than the EVM. Now, I don't think that means that the EVM dies. I mean, the EVM will continue to power some of the world's biggest DeFi applications like Uniswap and Aave and all of the value that's been created on Ethereum. Just the new applications, the new billion-dollar protocols will probably use something different. And again, we can make analogies to Web 2 here. Like PHP still powers 75% of the websites on the web, because like 60% of the websites on the internet are PHP, but it has a very like narrow set of applications that it runs. It will continue to run and continue to be maintained as long as those applications exist. But college kids now that come out of school, like they're not coding with PHP, they're coding with like Node or whatever, like some other more modern language. So I wonder if that resonates with you and if you agree, and like where there might be holes in my theory here. But that's sort of where I see things heading, and I wonder if you could share your thoughts on that.
I absolutely agree, and I think, again, this is one of the exciting things that the modular paradigm enables, right? Is in the past, right, it was very expensive to try to innovate at the execution environment layer, right? So either you had to convince the Ethereum community or some existing L1 to make a change to the sort of EVM, right? But that's really risky if there's already like assets and all this stuff, and that's why the innovation of the EVM on Ethereum has been so slow. People have all these AIPs, they never get shipped because it's just too, it's very dangerous and like fraught with, making a mistake. So like it slows it down from that perspective. Then your other option is like, okay, well, I'll just launch my own, new chain with a different version of the EVM that I'm going to iterate on. But the problem with that is, again, now you have to launch a new chain, which is extremely expensive. You have to bootstrap a new consensus network, issue a new coin, all these things. So like there was basically no way to innovate, or the only ways were just really slow and costly to innovate at the execution environment layer. And now with, and there's actually a lot of parallels to this of like pre-Ethereum, right? If you wanted to launch a new decentralized application, you also had to launch a new chain. Like Bitcoin, like there was like Namecoin and I don't know, I can't remember, all these different like, every time someone wanted to launch, anytime someone wanted to launch a new decentralized application, they had an idea that was different from Bitcoin, they had to launch a whole new chain. Until Ethereum came around and was like, hey, actually, we could just build a chain that enables anyone to launch their own application as a smart contract. And then once that was done, it was like, boom, it opened Pandora's box. There's this Cambrian explosion of new decentralized applications written as smart contracts because it just dropped the cost of innovating to almost nothing, right? It's like, okay, well, a kid in their college dorm room could like write a new smart contract and deploy it, right? And so that's what I think Celestia brings. It does the same thing, but at the execution environment layer, where now if you want to launch a new chain, let's say you want to launch the EVM, but with parallelization, or you want to launch the EVM like Manta with these opcodes that make verifying ZK things more efficient, then you can do that permissionlessly and basically for free, because it's just as simple as like writing it up, deploying it as a rollup on Celestia, and now like it's there. And I think, so I expect like an enormous acceleration of innovation in that layer. And I totally agree with you. The EVM is not the be all and end all. It is, kind of like, I think it's the most popular. It's kind of like very similar to PHP. It's something that works and has spread and has a network effect that I think is like very formidable, but I don't think it's at all like the end state of like where like Web3 blockchain development will end up. There's a lot of like exciting new execution environments, not just the SVM, but Move and WASM based things that I think are underexplored. And I think over time, like there's just going to be way more options that are going to enable new use cases and to just be more secure and have all kinds of benefits. So that's, I think, the world that we're heading into.
Great. I think that's a great note to end on. Nick, I want to thank you so much for spending some time here with me on the podcast today. Learned a lot about Celestia, about the go-to-market, the alignment with Ethereum in some ways, and also like the future of the modular ecosystem, which is very exciting. Feels like a brand new, I've been in crypto for 10 years, and it really feels like now is like a new era in crypto that is starting with the modular stack becoming reality. And so very excited to be a part of it.
Yeah.
Thanks again.
Well, it's my pleasure to be on the podcast. Thank you for inviting me. And I hope that people get inspired to, build something in the modular stack, whether that's a rollup or, sequencing things, rollup frameworks, applications on top of existing rollups. Like it's really an exciting time to be a builder in this space. So hopefully those of you out there listening will feel inspired to jump in and participate.
Great. Thanks, Nick.